Welcome to this video on sample means. By the end of this video, you should be able to calculate the mean and standard deviation of a sampling distribution of a sample mean and interpret the standard deviation. And you should also be able to use the normal calculations to determine a probability if it's appropriate, meaning is your distribution approximately normal. Okay, so today's scenario, how tall are we? So how tall are high school seniors in Georgia? Attached is the heights of all 50 high school seniors at a small high school in North Georgia. So I'm going to go ahead and do the sampling for us. So this is what I used. I had 50 students. They're numbered 1 through 50. And then there's their heights. And so I used my graphing calculator. I used math, and then I chose random int no repeats. So that's within a sample. I can't have a repeat. And I had it draw 5 at a time to give me my samples, so you know where the numbers are coming from in just a minute. So this set of data is represented in this dot plot for you. Okay, so what I want us to do is kind of think about what is the mean of this data. So this is all 50 students at a high school, so this is actually a population distribution, because we're talking about all of the people at a school. And from this population, we're going to draw some samples here in just a minute. All right, so where is about the middle of this data? Where is everything centering around? So when I was looking at this, I thought like right in here-ish is kind of where I thought the center of the data was. So I was thinking, I'm going to say that I think the mean is somewhere between 168 and 169 centimeters. Okay, and then our standard deviation. So we're looking, you know, we want to get 3 standard deviations out. We do have a somewhat, it's very stretched out, but it is a kind of symmetrical distribution there that I'm seeing. So when I looked at that, there's 50 students. 68% would be in the middle, so that's about 17 on each side. So when I counted that, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So like right in here would be 1 standard deviation. When I went the other way, I didn't feel it went further because this is a little less densely populated. So I was thinking it was really about, I don't know, 8 or 9 out in each direction, and then if I go another 8 or 9, I'd get my second, and then I would have my third standard deviation. So I was kind of playing with it that I think it's, I don't know, it's 8 to 9, somewhere in there. So I have seen questions show up on the AP exam where they ask, but so they're giving you the choices. These are multiple choice questions, and you can go in and look and say, if I go that far out each time, does that make sense for the percentages that have to be represented? Remember, you want to kind of think about the empirical rule there. All right. Always be able to identify what does a single dot mean. So this dot, it represents 1 student. And it's actually his height. And their height is, it's about 188, I'd say, centimeters. Okay, so be able to identify what your dots represent. So when I did my samples, I used that data sheet that I showed you. And let me show you what I got for my 4 samples. So I did 1 set to kind of give you an idea of what you would have gotten if we'd been able to do this in class. I just ran the simulation 4 times. Then I ran it a bunch of times to give us a sampling distribution. And so remember, this dot now, it's not 1 student's height of 180 centimeters. This is 1 sample of 5 with a mean of 180. Okay, because this is no longer a population distribution, this is the sampling distribution of X bar. All right, so let's take a look here. So let's look at our shape. Okay, we're talking just about this. So when we look at it, we can kind of imagine throwing that blanket over it. This one's a whole lot clearer to see actually than I think the other one. This one is roughly symmetric. So I'd say it's approximately normal. I see a single peak about 169 centimeters. Okay, so here there's 170, that's about 169, 168, 169, somewhere in there, and that's where our peak is. Our center, that's also where I think our center is. 169-ish, looking at this. And now our variability. Let's look at our standard deviation. So here it's only 160 to 180, and before we were 140 to 188. So obviously this is more spread out than this is, so that means this one's standard deviation is smaller than before. All the variability is smaller than before. And looking at it, let's see, I was kind of thinking if this is our center right about here, I was kind of getting that felt like my distribution right there. So about our standard deviation was maybe 2 to 3. So it'd be our standard deviation of X bar was somewhere between 2 and 3, I'd say. And of course we've got some decimals in here, and these were more graphed onto the whole number, so we'd have maybe just a tiny bit more spread. Wouldn't be a lot more, but it might help us see that distribution a little bit better. Okay, so now let's compare the two of these. This one we made, and then this one that we started with. So their shape, they're the same. So our shapes are the same. They're approximately normal. Their center, now we haven't calculated out exactly, but we were saying it was 168 or 169 here, and we said the same thing up here, and if you're looking, they are pretty much in the same spot. 168 to 169, so they're the same. And then the variability, the second one is much less variable. And that's because once you start taking samples, and you take enough samples, the variation will go down. The bigger especially the bigger the sample size, the less variation that you're going to have. So this is very similar. We had done sample proportions, and now we're talking sample means. So really it's a lot of the same idea, but of course the formulas are just a little bit different between them. What is the same is when we're talking about sample means, the mean of the sample mean is going to be equal to the population parameter. Whatever the number is for the population will be the same for the sampling distribution. Because here we had our population, and we had its center that we were kind of guessing, and then we had our sampling, and its center is in the same spot. So the sampling distribution mean is the same as the population mean. to get our standard deviation when we take a sample, so for your sampling, you're going to take the population standard deviation and you're going to divide it by the square root of n. Okay, so these are formulas. They are on your formula sheet. They're labeled pretty clearly under sampling distributions. So a big takeaway I want you to have is, if your population distribution is approximately normal, then your sampling distribution will be approximately normal. So what I want you to be sure you write down, if the population distribution is approximately normal, then the sampling distribution of X bar is also approximately normal. All right, let us go ahead and flip this over and summarize what I need you to be sure that you take away from this lesson. So I have 2 items that I want to tell you. All right, so the first one that I need to be sure you take away is, when we're talking about the sampling distribution of X bar, the center of the sampling distribution will equal the population parameter. Okay, and we've proven that several times, where if we show the whole population graphed out and then we take a bunch of samples, they center around the same number. And so that's why this is true. If you're using an unbiased estimator, this is going to happen. So that's your center, your variability, and in this one we're talking about standard deviation. When you take a sample, you're going to get your standard deviation will be the population standard deviation divided by the square root of the sample size. Now, a very important thing to take with this is the 10% condition must be met. If you're going to use this standard deviation, the 10% condition must be met, or you have to use a different standard deviation. Okay, and we're not, that's not within our scope. And remember, the 10% condition is your sample size has to be less than or equal to 1/10 of whatever the population is. Okay, so check this condition. You're going to have a question in your Check Your Understanding today that talks about the standard deviation. Make sure you're doing this when you answer the question. All right, now our shape. That's what we were just talking about. If your population distribution, so if your population distribution is approximately normal, then the sampling distribution of X bar is also approximately normal. And to calculate that out, you've got to draw your picture. Always remember to draw the picture. You're going to center around your sampling mean. So your n, and it's going to be the mean of your sampling distribution, and the standard deviation is the population divided by the square root of n. Okay, then you would show whatever your score of interest is here. So this is the mean of the population, so maybe we ask for a particular X score. So to find your Z-score, you're going to take whatever that value of interest is minus the population mean and divide it by your sample standard deviation. Okay, so when you're doing these, really the formula for Z-score never changes. When I show you these and they all look a little different, it's because I'm showing you in the context of if we're talking about means or proportions or the difference of proportions, and soon we'll do the difference of means, that where the numbers are coming from. Okay, so when you do your Check Your Understanding to turn in, you've got your scenario, and so this is your population mean. This is your population standard deviation. And the one thing I want to point out is in question 1, they talk about a randomly chosen U.S. teen, so that's a sample size of 1. as opposed to when you come down here to this next one, they have an SRS of 10, so that means your sample size there is 10. That will make a difference. Think about it with your formulas. So if you have any questions, let me know. Looking forward to see you in class sometime soon.